But in this, but the goals here are, first we're gonna see what a polynomial even is, okay? We're also gonna see how we add and subtract polynomials. That's what we're also gonna see, how you add and subtract them. We're also going to see how you multiply them. I'm actually going to show you two different methods for multiplying them. One of them is more visual than the other. So I just thought I thought it wouldn't hurt to show both methods. I know some people like prefer one method over another, and that's fine, your choice. Okay. All right, so we have that. And later on in the course, I don't remember what chapter, I want to say chapter 3, we'll get into polynomial division. But we'll see that later. Okay, so before we get the polynomials, we have to first consider what monomials are. And monomials are essentially polynomials with one term. So a monomial in the variable x, by definition, it's just a term that looks like this. So again, this is all terminology and definitions, where the a is a constant, it's a number. So it could be like 2, 8, 1, or anything like that. We know x is the variable. K here is a non-negative integer, meaning it could be 0 or a positive integer. And there's, a few conventions people take. If the a here is not 0, k is called the degree of the monomial. So the exponent of x, the power of x that is, that's the degree of the monomial. If a also is 1, we don't write a. So in other words, 1 times x to the k, we would just leave as x to the k. And if the k is 0, we don't write it either. So in other words, a non-zero constant with no variable, that's of degree 0. I know there's a fair amount of stuff here. I know. So a non-zero constant with no variable is of degree 0. I mean, I do throw this in here because I think it helps people. You can almost think of x to the 0 as 1. Kind of like from before, we had a to the 0 was 1, right? I mean, this is really not precise because the x here, if it's 0, then this is not going to make sense. But, you could think of this as like a tool to help you, although it's really not precise. That's why I put it in quotes. But if the a here were 0, then the monomial is just 0, and the degree is undefined. So 0 is a monomial, but it doesn't have a degree. I don't remember why it's defined that way. I think I saw it once when I was in grad school. I think it's just for convenience. But non-zero constants, those are monomials of degree 0. And if you have something like this, where the a is not 0, the exponent of x is the degree. And again, if a is 1, we don't write 1 times x to the k. We don't write 1 as a if the coefficient is 1, we don't write it. So if you don't see a coefficient, it's understood to be 1. Okay. Let me show some examples. So for instance, let's consider 3 times x, right? This is a monomial. And this is of degree 1 because just like with exponents we saw, remember how we said a to the 1 is a? Well, if the exponent is 1, we don't write it. And that's what we have here. 3 is the coefficient. The exponent of x is 1. We don't write it. The degree is 1. Okay, that's good. 5 is a non-zero constant, right? And there's no variable here. So 5 is a monomial of degree 0. X alone is a monomial. Its degree is 1. Again, if the exponent is 1, we don't write it. The coefficient here is 1, right? So it looks like there's no coefficient, but it's actually 1. The coefficient is 1. That's with monomials. You know, mon meaning one term. Are there any questions about this? Yeah?
So basically, where it says 5 is a monomial of degree 0, just because it has an x, that means the degree is 0, basically?
It's because there's no x here, that's why.
Right, that's what I meant to say. Okay.
That's okay.
But if there's an x there, then the degree will be 1.
Well, if there's an x here, then the degree would be the power of x,
Right.
whatever that exponent is.
Okay, cool. Thank you.
Okay. Yeah, another question? You're welcome. Another question?
Is the degree the same thing as an exponent?
Not in general, but for monomials it is.
Okay, thank you.
You're welcome. And again, it's only for the exponent of the variable. Okay. I know the terminology is a little confusing. I understand that. So if you have questions, don't be afraid to ask. So.
And if it's just x, you assume that it's to the degree of 1, like 3x right there, the exponent's 1. You just assume that.
Exactly.
Okay.
Yeah, if the exponent is 1, we don't write it. That's just a convention people take. I know I didn't point that out in the notes from before, so I am sorry about that.
And so for like the bottom one, so x is a
Mhm.
monomial of the degree 1, the coefficient is 1, so you assume that it's x to the 1 power, and you also assume that x is just 1 there?
Well, we didn't write the coefficient here, right? So we assume it's 1 times x, right? Because for a monomial, we have a times x to the k. But since the a is not there, we assume it's 1.
Okay, fair enough.
Okay. Good question. Okay, this is cool. Okay. Okay. Now with monomials, you can add and subtract them, but you do have to be careful. And that's where this stuff comes into play. Basically, we have this notion of like terms. We say that two monomials in a same variable of the same degree, those are called like terms. Two monomials, so I'll say it again, two monomials in the same variable with the same degree, they're said to be like terms. And if they're not like terms, if monomials are not like terms, then we just call them unlike terms. Okay, so how do we add and subtract? Well, we only add or subtract like terms. And you do that by just adding or subtracting the coefficients. That's what this is trying to tell. That's what I'm trying to tell you here. Right? These are like terms. They're both in the variable x, and the degrees, both of them are m, right? That's the exponent of x. And how do we add them? We just add the coefficient. The coefficients. Subtraction, same idea. We just subtract the coefficients.
Are the equations on the right on both sides, are those basically just like partially factored?
Well, yeah, I mean, you could think of it that way. I'm just trying to illustrate how you add and subtract the monomials. But I mean, you could distribute, I guess, but we're just adding like terms or subtracting like terms.
Okay, thank you.
But you're welcome. I don't know if that, I hope I didn't make it worse by saying that. Make anything more confusing. But that's what I'm trying to say here. If you have unlike terms, you don't combine them. You just leave them alone. So we're not thinking this is factoring. I'm just trying to show you that you combine only the coefficients. Notice the degree, the m here doesn't change. I've seen students, what they would do in the past is when they're adding, they would also add the exponents together. Don't do that, okay? When you add or subtract, the exponent doesn't change.
You only add and subtract when you multiply and divide for exponents, right?
You only add and subtract the exponents, right, when you're multiplying and dividing. We'll see that later. I think we won't see that. I'm not sure if we'll see that next class, but we might. So, all right. And here's just some other examples. For instance, x and fourth x, right? These are like terms, right? They're both in the same variable x. They both have the same degree, right? Remember, the exponent of x, it's not written, so it's understood to be 1. So they both have the same power of x, so to say. Exponent of x, excuse me. And remember, it looks like there's no coefficient, so it's understood to be 1. So this sum is the same as this, and this is just 5 times x. So this is 5 times x. Here, we have 1 plus 5 times x, but these are not like terms, right? This here has degree 1. This here is degree 0, right? It's a non-zero constant. There's no x there. So we leave this alone.